very simply, how do I create an array, how do I access an array, and how do I loop through an array. And then we also went through a variety of helpful functions that are built into the array class in JavaScript. And so that means these functions are things that every array in JavaScript organically has, and we can make use of. For the workshop, what we did was we actually went through and we actually had you build some of those functions from scratch, so you kind of know how they work underneath the hood, right? These functions are meant to be helpful, but they're not black boxes, right? They're not some kind of super magical thing that's beyond a normal programmer's realm of understanding, and we just wanted you to see that. And as a good rule of thumb in programming is you never want to have these black boxes. You never want to have anything where you're using and you don't quite know how it works. Usually that leads to trouble further down the road. So anything that they use, even if you don't want to try rebuilding it, make sure that you at least have a good understanding of what's going on. So if something does break, you have some way of kind of fixing it or looking at the data yourself. Okay, so today we're going to keep pushing in our session on arrays, and we're going to talk about a few more things. The first one is just another function that could help you when you're using arrays, and then we're also going to get into the idea of nested arrays. Okay, so continue on in our session of methods that are built into JavaScript arrays are really helpful. One of the first ones we'll cover today is called splice. It sounds like slice, and actually a ton of people get these two confused. In fact, whenever I use slice or splice, I actually usually pull up the documentation for them just so I can make sure that I have the arguments correct, because they sound very similar, but they actually do very different things. Okay, so on Friday, when we talked about the array methods, we did push, pop, shift, and unshift, and those four essentially allowed us to be able to add or remove elements from either the beginning or the end of the array. Splice is essentially the more comprehensive method that actually lets us be able to add or remove elements from anywhere in the array. So now we're no longer just confined to the beginning or the end. So for splice, the first argument is an index, okay, and that's basically the position at which we start. The second argument is going to be the count, and that number is going to tell you how many elements we are going to remove starting at the position that we denoted in our first argument, and inclusive of that. So here on line 11, or rather on line 9, I make an array called names. On line 11, I call names.splice, and I pass in as my first argument 1, which says go to position 1, which is John, and the second argument is also 1, which says starting from and inclusive of John, let's remove one element. And lastly, what splice does is it returns the elements that just removed. And so right here, we're capturing the elements that were just removed in this variable called singleton precedence. So when I console log out names and when I console log out singleton precedence, in the names array, I see that I was able to successfully remove one element, right? And I removed the element that used to be at position 1, and I removed one element from that position. So John is gone, and now I just have left with George and Thomas. And the value that got returned, that we stored in singleton precedence, that was an array of everything that was removed. And once again, in our case, that was just the string John. Okay. Similarly, we're actually able to remove multiple things too, right? So now we're once again saying let's start at position 1, which is George, and now let's remove two elements starting from and including George. So that means George and John now get removed. And once again, we still return that in an array. One of the things we'll see later is that if you choose not to remove anything, you can actually do 1, 0, and that will do is what that will return is that will actually return an empty array. So you can actually feel pretty comfortable that whenever you use splice, you are going to get back an array, right? It's just a matter of what's inside the array coming out of the splice function. And so far we've talked mostly about removing elements, but what if I want to add in new elements? Well, that's literally as simple as just saying every argument after the second argument, as many things that you want to add at that position, you just add in whatever it is you want to add. So here on line 5, what we're saying is, all right, when I look at splice, when I look at name, I want to go to position 2, so that's Pete. I want to delete one thing, so that's Pete. And in that position, I now want to insert Ringo. And so now when I look at my original names array, I see Paul, George, Ringo, and John, right? Because I took out Pete, I added in Ringo. And when I look at the elements that were removed, i.e. what was returned from my splice function, I see an array with one element, which is Pete. And lastly, line 5 is kind of our final example here on splice. Here we're actually saying I don't want to remove anything. I just want to use splice as a way to add in new elements. And notice how on line 5 there I have two arguments, right? I have Pete and then Stuart being fed into the splice function. All that means is that I'm going to go to position 2 right now, which is where Ringo is. Okay, I'm going to delete 0 items, and I'm going to insert there Pete and then Stuart. And so notice how now it becomes Paul, George, and then at position 2 we insert Pete, followed by Stuart, and then our original array had Ringo and then John. Right? So the original array got 2 elements added, but we removed 0 elements, and therefore we returned a blank array. Sorry. Any questions on splice? Cool. All right then. And once again, let me just kind of reemphasize this point. Splice does change the original array. So when you use slice without a p, when we did slice, all that did was make us a copy of the array. Okay, so it was actually very safe in the sense I didn't change the original array. Here, when we use splice with a p, it does change the original array. So be careful when you use it that you're not removing or adding things that you're not intending to modify. Okay. The next element the next method that we're going to take a look at is called the dot join method. And dot join basically is a very simple way for us to take all of the elements in in an array, and then join them together into a string. So this method is actually very useful if I have a list of different things to just add them together into a single human readable string. So let's take a look. Here I have Paul, George, John, and Ringo again from my previous example. If I just do names.join, what that does is it doesn't change the original array, right? Dot join leaves the original array unchanged, but what it does do is it joins all those into a single string and returns that new string. Here we captured that return value in this variable called join string, and when I do type of join string, it says string, and when I take a look at it, all it says, or when I look at the value of join string, all it is it's a string with Paul, George, John, and Ringo as a single string separated by commas, right? So that's one single string. All we did was we added the comma character in between each element. Now, in the previous example, we called join and we didn't put in any arguments, right? We just did a join or we just invoked it. And so by default, what it does is, as we saw, is it inserts a comma between every single element. However, sometimes we may want to specify what we want our joiner to be, right? What we want to join with. And so whatever you put into that join function, whatever you pass in as the first and only argument, then that becomes that becomes what is used to join the elements together. So here I'm passing in another string into my join function, and it's space and space. Okay, so now when I do names.join, I now get back a single string still, except now it's Paul and George and John and Ringo, right? So if I don't pass anything in, then by default, .join says, oh great, you want a comma there. If you want anything else, you need to tell me exactly what you want, and I'll use it, right? And so it's kind of a nice handy way for us to actually say, like, hey, now I can insert a join in between every single element. I don't need to worry about having one extra join at the beginning or the end of the function. It's just a nice little shortcut.
I'm sorry, real quick question.
Totally, go ahead.
At what point when we use something like the join string, or rather the join method?
Usually it has to do with usually what happens is if you say I have if I give you a sentence, so because strings are not mutable, a lot of times a way to modify a particular string is to take a string, use a function called .split, which actually takes it and breaks it up into different elements in an array. You make the changes you want, and then you join it back together into a string. it is more of like because the final output is a string. It is a bit more of a select use case, but we just wanted to make sure that you were aware of it.
Thank you.
Yep. Cool. And the last method that we're going to talk about is the concat method. Concat method is basically the same, like with string concatenation. We just do string 1 plus string 2. This does the same thing, except the way we call it is a little bit different. So the way we call the concat method is if I have two arrays here, one's called older, one's called younger. On line 9, I create a new variable called altogether now, and I set it equal to one array dot concat, and I pass in the other array. Okay. The one mistake here that I see a ton of people always make is notice how here on line 9 we're not modifying either the older array or the younger array. Instead, we're just taking the two arrays you gave us and we're going to combine them and give you back a brand new third array. Okay, so if you don't store whatever that concat returns to you in a variable, then that gets lost and there was no point in running it. Essentially, right? It's like running .slice, but not capturing what .slice returns to you in a variable. Here, when I do .concat, once again, I'm not changing either of the two arrays that I'm concating. I am literally just saying, hey, here's a brand new third array that I made from scratch from the elements you gave me. In this case, order does matter in that the older array in this case will come first, followed by the younger array. So whatever calls a function, whatever calls concat, that comes first, and then whatever is passed into concat comes subsequent. And once again, on line 12 there, we're just proving to you that the older array does not change, or neither does a younger. We're just capturing both of these values into a brand new array. Okay, so that was pretty much kind of the end of our session on some helpful array methods. Like I said, these exist in all JavaScript arrays, so definitely get comfortable with them. You'll see people use them quite a bit. Okay, so the last thing we'll talk about in our session on arrays is this idea of nested arrays. On the very first session, when we talked about arrays, we mentioned arrays can hold any types of value. So it can be strings, numbers, booleans, etc. And now we're saying, yep, it can also hold other arrays. So nested arrays are essentially arrays that contain other arrays. Here, if I look at the array related things on line 3 there, don't get tricked. This is an array with only 2 elements. Okay, related things is an array with only 2 elements. Each of those elements happens to be another array, and each of those other elements happen to be another array with 2 elements. So in this case, related things is the first element in related things is an array with Windows and Mac OS, and the second element is an array with the elements New York and Chicago. Okay, on line 6 there, we see actually one way for us to access it, because JavaScript's going to evaluate this statement from left to right. One actually pretty straightforward way for us to access the inner elements is to say, great, go to related things, get me the first element, or sorry, give me the element at position 1, give me the second element colloquially, and then get me the first element of that. Okay, so here what JavaScript's going to do is going to go to related things. At index 1, that's the array New York, Chicago, and then index 0 of that is going to be the string New York. Okay, so once again, related things, the first element is another array. If I want to chain these together, if I want to kind of go into the nested arrays, I just use the square bracket as a way to go deeper and deeper into the elements. And then lastly, once again, related things is an array with only 2 elements. Okay, so it's very possible for us to have elements are also arrays, and the chaining there we see on line 6. That's a really handy way for us to access the elements inside the nested arrays. So looking at nested arrays, one thing that we've done so far is we've actually been able to use for loops pretty effectively to go through the elements in an array. Well, how does that change now once we have nested arrays? And so here I have RSVP groups, and it's an array, yes, but the array has, we'll say, 2 types of elements, right? We see that it has some arrays, but it also has some strings like Jack. And so in order for us to loop through this array, the looping part of it doesn't change, but what we do with it absolutely does. Okay, so here on line 3, I still create the for loop that hopefully by now we're all very comfortable with. I start at I equals 0. I say I is less than this array.length and I plus plus. And on line 4, I still say let element equals whatever element is at that index in RSVP's group, our RSVP groups. Okay. The only problem now is we don't know what element is. Is element a string or an array? And that's going to vary depending on which element we're at. So the easiest way for us to determine whether or not something is an element, or sorry, something is an array or a string is just to test it out. And so here on line 5, we're actually going to have our if statement, and we're going to make use of what we learned on Friday, which is this array.isArray function, and we're going to pass an element. Now remember, array.isArray is a function that will test whether or not something is an array, and it gives back only 2 possible values, either true or false. Either something is an array or it's not. Okay, and so if this if clause so if this expression returns true, then that means we are dealing with an array, and the way for us to properly go into that array is to actually write another for loop that now traverses that inner array. Be careful, okay? Let's take a look at how this for loop is different than let's take a look at how the for loop on line 6 is different than the for loop on line 3. First off, we shouldn't really use I anymore, right? Because in this case, I is already being used as an index for the outer array. It won't break our code, but it's just bad form. So here what we're actually going to do is we're actually going to use another letter to keep track of our index. And general programming convention says you just want to use the next letter of what your current index is, right? So on line 3 we use I, on line 6 we'll use the next letter, which is J. We start once again at J equals 0, and now we do J is less than element.length, because once again now we're no longer looking at RSVP groups, right? We are looking at only one element in RSVP groups, and that element happens to be an array, right? Look at line 4 there. Element is equal to the element at the ith position of RSVP groups. Okay, so here once again we're creating a brand new index tracker. We're calling it J, and we're only saying, hey, how long is this inner array? Let me traverse through this inner array. Okay, and now for every single element, for every single element inside this inner array, we say let name equals element index J, which says in the inner array, get me the element that's in this quote unquote element variable. Okay, and then we console log out name. And so far, all we've done is in this function, all we've done really say is, great, if I go through RSVP groups, if I encounter an array, I now have a function that is well equipped to make another for loop and go through every single element inside that inner array. But we still have our condition where sometimes we just have a random string, right? Like in this case, we have Jack. Well, Jack would not trigger the if condition on line 5, right? If I put Jack in array.isArray, I get back false. So what I do? Well, now I need to write the other half of my else statement. And if I encounter a string, well, then I can just do whatever it is I want to do with it originally, which in this case is just to print out the name of the person, right? Print out the element. And now I've finished. And what I've done is I've created a for loop that actually goes through every single element in this for loop, and it checks. It checks to see if are you an array or a string. If you're a string, I will handle you one way. In this case, all we're doing is printing it out. On the other hand, if you're an array, I can actually write another for loop that then goes through every element inside that inner array, or inside that nested array. So this is going to be kind of the most direct way we have as of now for us to go through and access every element inside a nested array. So when will we use nested arrays? One of the reasons why we use nested arrays is actually for very visual representation purposes. Actually, nested arrays are actually very good tools to help us represent this concept of a grid. So here on lines 7 through 11, it's all grid is it's a nested array, and all it contains is 3 elements, but each of those elements are an array with 3 elements themselves. And so when I printed out like this, it's effectively what I kind of have is I kind of have a data type that can represent a 3x3 grid. Now, be careful because if I was just a console logout grid, it wouldn't print out this way. Okay, it would print out probably all three elements on a single line. And so to the naked human eye, it may not look like a grid, but the idea here is that conceptually, we essentially have something that we are able to represent as a grid, right? Like if I just add, enough white spaces in different places, then I can basically get back something that could be viewed as a grid. So even though it may not look like a grid, depending on how you print it out, it does represent a grid fairly well. And so if I have a grid now, I'm actually able to now do things with a grid. And I'll talk about like what examples of some of those things are. If I want to get a particular row in grid, well, it's pretty easy, right? The row 1 is just line 8, which is just the first element in grid. Row 2 is line 9, the second element in grid, and row 3 is line 10, the third element in grid. So that's pretty straightforward. There's not too much complicated there. Where it gets tricky is actually if I want to get the first column in grid, right? Because if I want to get the first column in grid, if I look at line 13, what we're actually doing there is, notice how first column starts off the array. So we're creating a brand new array, and inside that array, the first element is going to be saying grid index 0, so get me the first row of grid, and get me the first element in the first row of grid. That's my first quote-unquote element in my column. The second element in my column says, go to the second row in grid, right, grid index 1, go to the second row in grid, and get me the first element there. And then lastly, go to the third row in grid, and get me the first element there. And so now what I've done is on line 13 is I have created a representation of the first column by going through every single row and grabbing the first element there. If I want to grab the second column, then I would still need to go into every single row, except then I would grab the second element there, and so on. So that's the part where it can be a bit tricky in terms of making a column, is that it's just that you need to be careful that you actually have to go into every single row and grab the column value that you want. Okay, and so one really good way for us to practice this is we have opened up an optional project for you called the Sudoku project. Essentially, what we're having you do is we're having you build a bunch of functions that can validate whether or not a Sudoku solution works. Hopefully, everyone is pretty familiar with what Sudoku is. If not, then we also explain it in the workshop. But essentially, it's just a way for you to kind of get comfortable with using nested arrays and thinking of it kind of as a grid, right? Because with a Sudoku, essentially is a numbers game that's played on a 9x9 grid, and so in order for us to do anything with it, we have to kind of be comfortable with traversing through the nested arrays. Okay, I'll pause here. Are there any questions on anything I've covered? The methods that we talked about were splice, concat, and join, and then nested arrays we just did. But effectively, the summary there is just be careful, because in order to access every element inside the inner arrays, you need a second for loop to do that, or you need to chain together your bracket notations so you are able to access the elements inside the inner arrays. Any questions? No questions. Wow. Everyone feels pretty comfortable with this?